Let n greater than or equal to 2 be a natural number, and f map 0, 1 to r be the function defined by f of x equals, okay, a whole bunch of different possibilities depending on the value of x. If n is such that the area of the region bounded by the curves x equals 0, x equals 1, y equals 0, and y equals f of x is 4, then the maximum value of the function f is what? Okay, and we know that based on the section of this exam that the answer is a non-negative integer. Okay, so I noticed that each of these sections of x, all the piecewise defined sections of x, they're all quadratic with respect to x. And we're being asked about, basically asked for an area under a curve. We're told it's equal to 4. You know, the quick way to set this up would just be to write this area as an integral, compute all of the, we'll have to integrate over 4 separate values, 4 separate pieces of this function, evaluate it at the endpoints, simplify that whole thing, set it equal to 4, and then that would allow us to solve for n, but then we would have to substitute that back into the function and find out what the maximum value of the function is. Is that the best way to do it? I mean, I don't see, in order to figure out what the value of n is, we're going to need to compute the area under the curve. I think that's just what I'm going to do. I'll compute the area as a function of n, solve for n, knowing that the area is 4, and then try and figure out what the maximum value of the function is. So it's just going to be a lot of sort of tedious computations, but okay. I misspoke. They're not all quadratic, these functions. They're all linear with respect to x. So maybe some of these will actually be easier to figure out because we just have, they're all going to be trapezoids, right? So this should be a little bit easier to figure out. I'll still do them one at a time, but I'll try and work rather than, I'm not actually going to integrate these things. I'm just going to use the geometry of each of the shapes. Okay, so I've solved that n is equal to 8, and what I need to do now is go back into each of these functions. I know the maximum value of f is going to happen at one of the endpoints because you know, the function it's piecewise linear. It's always a straight line. So let's just list off all the possible values of f at these endpoints. Okay, so the maximum value of the function is going to be n, which is equal to 8. Because f attains the value of n at a bunch of places, and yeah. And anyway, there's not much more to say about that. I'm not going to graph the function, but you know, if f is a linear function, then it's going to attain its maximum at one of the endpoints. So we've evaluated the endpoints. We find out that in many times it's equal to n, and the endpoints take on the values only n or 0 in a bunch of spots. I probably could have used that earlier, realizing that if I knew that the value of the function was actually n at a bunch of the endpoints, it's just a bunch of straight lines going from 0 up to n and back down, it would have been a little bit easier to simplify the area calculation, but I'm fine with doing it this way. So yeah, 8 is my answer, but if I find a mistake or have more to say, I'll put it down in the description. Thanks for watching.